Good morning, students. In this video, we will explain Class 12th Chemistry Chapter Alkyl Halides. Today's topic is Chemical Properties of Alkyl Halides. After the explanation of chemical properties of alkyl halides, I explain some points of alkyl halides which defines the alkyl halides. The replacement of one or more hydrogen atom in a hydrocarbons by corresponding halogen atoms like fluorine, chlorine, bromine or iodines. The compound is formed called halides or HaloAlkanes. These are the alkanes, the replacement of H or hydrogen ion and replaced by halogen groups. Here X is the halogen groups: chlorine, bromines, iodine, fluorines. Then alkyl halide is formed. These are the primary alkyl halides. All hydrogen atoms are replaced by halogen groups called secondary, tertiary alkyl halides. The alkyl halides are highly reactive. The order of reactivity is halogens, iodide, bromide and chloride. The nature of halogen atoms. Then the types of halogen atoms are tertiary alkyl halide, secondary and primary. The type of halogen atoms or the number of halogen atoms. Primary alkyl halides, when one halogens are attached and one hydrogen are replaced. Secondary, two hydrogens are replaced, then two halogens group attached, and tertiary, three hydrogen groups replaced, and this place three halogens atoms are attached. Then reactivity of alkyl halides depend upon the replacement of H ions and placed on halogen atoms or halogen ions. Among the primary alkyl halides of order of reactivity is, so this lines, these are the primary alkyl halides which attached only one alkyl halogen groups. These reactivity order is this: methyl halides, ethyl halides and propyl halides. Methyl halides is the more reactive than alkyl halide, ethyl halides or propyl halides. The nature of reactivity depend upon the alkyl halides compound C and halogen bond. These bond which formed carbon and halogens in middle position called polarized covalent bond. These bond shows large differences in the electronegativities of carbon and halogen atoms. The halogen is far more electronegative than carbon and tends to pull the electrons away from carbons. So, in easy way, alkyl halides which jointed the halogen group, this is more highly reactive. So electrons electron pulls the side of halogen, then halogens have a small negative charge and carbon have a small positive charge. So this charge, a small positive charge and a small negative charge. According to polarized covalent bond, the polarity of carbon and halogen bonds in methyl halides. In decreasing order, methyl chloride is more polar than methyl fluoride. It is more polar than methyl bromide, and last is the methyl iodide. But the reactivity of methyl halide is the just opposite of polarity of methyl halides. So the reactivity of methyl halides, alkyl iodide is more reactive than alkyl bromide. Alkyl bromide is more reactive than alkyl chloride, and alkyl iodide is less reactive than alkyl chlorides. Here R represent the alkyl groups. So the reactivity of alkyl halides are just opposite the polarity of alkyl halides. The reactivity of alkyl halides depend the other points of bond dissociation energy. What is the bond dissociation energy and what is relation of reactivity in alkyl halides of bond dissociation energy? The energy required in the cleavage of carbon and halogen bond is called bond dissociation energy. The cleavage of bond carbon and halogen, which energy requires this energy called bond dissociation energy. Which compounds bond dissociation energy is higher than reactivity is smaller, because when bond dissociation energy is higher, then breaking the bond is not possible or very difficult. So this reactivity is very small. Bond dissociation energy is directly related to size of the atoms. When size of atoms is increases, then bond dissociation energy is decreases. Carbon iodide bond is easily cleavage than carbon chloride bonds, because these bond dissociation energy is lower than carbon chloride bond dissociation energy. So it's easily cleavage and its cleavage is very difficult. Here we discussed some important reactions of haloalkanes which shows chemical properties of alkyl halides. Some important reactions of haloalkanes are: first reaction shows by alkyl halides, elimination reactions or dehydrohalogenation reactions. Second, reduction reactions. Third, reaction with metals. And last, nucleophilic substitution reactions. Nucleophilic substitution reaction is the important reactions which place by haloalkanes or alkyl halides. First I explain elimination reactions or dehydrohalogenation reactions. The removal of two atoms of group of any reactions, one being generally hydrogen and secondary L is leaving group, resulting in the formation of pi bond or unsaturated hydrocarbons, and leaving group are released or eliminated. So this reaction called elimination reactions. So these reactions, these carbons release the hydrogen and these carbons L or relieving group or some others then forms the alkenes are unsaturated hydrocarbons or pi bonds. Here we show first pi bond and second sigma bond, and leaving group are released. This reactions called elimination reactions and hydrohalogenation reactions. In the presence of a strong base, this reaction is completed. For example, the main example of elimination reaction or dehydrohalogenation reactions, when ethyl bromides reacts a strong base potassium hydroxide H is the hydrogen atom and these are the leaving group. These are both eliminate and form alkene or pi bond, and these are the leaving group we are released. So this reaction is called elimination reactions. The elimination reactions are divided into two classes. First, E1 reactions and second, E2 reactions. E1 reaction stands for unimolecular elimination and E2 reactions stand for bimolecular eliminations. First we explain E1 reactions or unimolecular elimination. E1 reactions divided in two steps. Step 1, when alkyl halides ionize to give carbocations, and second, carbocations loses a proton from beta carbon atoms by a base to form alkene. Step first and second combining form complete E1 reactions. These are the step first which alkyl halide ionized or by ionization gives carbocations which forms positive ions and give the alkyl or halide group in free. In step second, these carbocations react with base and loses one proton, gives alkenes or pi bond. Here we show these carbocations loses his protons and form two methyl propenes or alkenes or pi bonds. Here we show the double bond, one are pi bond and second or sigma bond. So the elimination reaction is complete in two steps. Step first, which forms carbocations, this reaction of ionization process, and second, these carbocations loses her protons and gives alkenes or pi bonds. So this even reaction is completed. The second is the elimination reaction is the E2 reactions. In E2 reactions, it is bimolecular since substance and base are involved in the rate determining steps, and the product obtained takes place through the formation of transition state. In E2 reactions, ethyl bromide eliminate in the transition state. After transition state, then form ethene and ethyl alcohol and bromide is released. So reaction E1 and E2 combinate condition complete elimination reactions. In elimination reactions, if the formation of more than one alkene is possible in these reactions, first butene 2 and second butene in. If in elimination reactions more than one alkene group is possible, the main product of obtained by elimination of hydrogen from the carbon having least number of hydrogen or more substituent alkene is main products called Ch-1 rule. When in elimination reactions more than one alkene is formed, then this rule is called Ch-1 rule. In first step, this carbon is least number of hydrogen, then form butene 1, and this carbon have more alkene substance is substituent, then butene 2 is formed. Then this process is called Ch-1 rule or Ch-1 rules. Then elimination reaction is finished. Next reactions is reduction reactions. In reduction, formation of alkanes with used many reducing reagents. These are all reducing reagent are here with helps the formation of alkanes and completion of reduction reactions. First, H2 or transition metals like nickel, palladium and platinum. Next, zinc dust in ethyl alcohol, Zn and HCl, sodium in the presence of ethyl alcohol, strontium in the presence of HCl, phosphorus in the presence of hydrogen iodide, and lithium aluminium hydrate in the presence of ether. These are all reducing agents which helps complete the reduction and formation the alkane. So these reactions hydrogen in presence of metal catalyst such as nickel, palladium, which reduced the halogen and forms alkanes, and hydrogen halide is released. Then the next step or next reaction, when bromoethane reacts the hydrogen reduce the alkane or bromine in the presence of nickel or palladium, then forms alkane and produce HBr form. The next is the if nascent hydrogen. These are the nascent hydrogen. Nascent hydrogen used in HaloAlkanes to help of zinc in the presence of catalyst ethyl alcohols or SnHCls, then forms alkanes and hydrogen halide. The next example is when chloroethane reacts nascent hydrogen in the presence of sodium and catalyst is alcohol, then form ethane and release hydrochloric acid. Nascent hydrogen reduced the or replace the halogen and forms alkane or ethane. The next reactions, hydrogen iodide or hydroiodic acid in the presence of red phosphorus, haloalkanes convert in alkanes. So this example, chloroethane reacts hydrogen iodide in the presence of red phosphorus, then gives ethane and iodines are released. These all of reactions complete and forms the alkanes and complete the reduction process. Without reducing a reagent are not possible the reduction reactions. One reducing reagent, lithium aluminium hydride, is help to aryl halide are reduced and eliminate the alloy and form benzene. So alkyl halides not used this reducing agent. These are the aryl halide because halogen group attached in aromatic compound, so this called aryl halide. These reducing agents are used in aryl halide to form benzene and release hydrogen chloride. Now I finished the two properties of alkyl halides, which shows chemical properties of alkyl halides, elimination reactions and reduction. The next video I explain reaction of metals and nucleophilic substitution reactions. Now today's homeworks, write down and complete it. Question first. Explain the Sergeff rules in other examples. And next question is, the reactivity of alkyl halides depend the polarity of carbon and halogen bonds. Explain in detail. Thank you. Have a nice day.